So next we have binomial distributions. So this tells the probability that counts the number of successes in n trials. So they have to tell you n, the number of trials. It has to be binary, two outcomes, success or fail, independent as well. It has a fixed number of trials we call n, like I said. And the probability needs to remain the same. The probability of success needs to be the same all the time. So there's two formulas. The mean is n times p. That makes sense, right? The number of trials times the probability of it happening is going to be the number of successes. And the standard deviation is the square root of n times p times q. But you're mainly going to use the calculator, Staplet, for that because it tells you the mean and standard deviation. So let's look at an example. At spring training, 80% of the players arrive on time. If I were to take a sample of 25 players, what is the probability that at least 15 of these hot shots will be on time? So let's take a look here. N is the total number of people. It's going to be 25. And the probability that they're on time is 0.80. So I'm going to put those two in Staplet, 25 and 0.80. And I'm looking for the probability that it is at least 15, greater than or equal to 15. At least 15, right, are going to be on time. So I'm going to go to Staplet, and I'm going to use binomial distributions. And it says that 80% are on time. Whoops, that should be on P, 80%. And we're taking a sample of 25. So 25 players on this, a sample of 25. And 80% are on time. And they want to know what's the chance that at least 15 of them will be on time. And so let's look at the binomial distribution and kind of read how it works. The chance that exactly 15 will be on time is 1.18%, right? But that's not what they asked. They said at least 15. So go down here, and one of your choices is at least 15. And it looks like most of the time it's like 20, 21. So most of them, there's a pretty good chance at least 15 are going to be on time, right? Because most of this distribution is above 15. So I expect a high number here, and that's what I get. 99.44% of the time, at least 15 are going to show up on time. All right, so the probability of at least 15 is 0.9944. Now, they could mix it up on you as well and say, what's the probability that at least 3 of these hot shots will be late? At least 3 will be late. Now, this is talking about being late, and P is the chance that they're on time. But in this part of the problem, we're not talking about on time. We need to figure out the probability that they're late, which would be 0.20, right? 20% are late. We need to put that in the Staplet, 0.20 with 25. So 25 and 0.20. And at least 3, there's a 13.58% chance that exactly 3 will be. But we want at least 3. And that is 90.18%. 90.18%. So the chance that at least 3 will be late is 0.9018. So be careful about that. They could ask it either way. And that's one of the things about a binomial distribution. Another thing they could ask is, let's find the normal approximation of this. And to find a normal approximation, what you do is we want to find the approximation that at least 3 of them are going to be late. So let's go to binomial here, and there's the mean and standard deviation. The mean is 5, the standard deviation is 2. 5 and 2. So I'm going to take those numbers, 5 and 2, and put them into the normal distribution. Now remember, this is an approximation. It won't be as accurate but there are situations where you would have to use it. So I want at least 3 to the right of 3. Whoops, 3. Because we average 5. And that is 0.8413, 84.13%. 0.8413. So that would be my normal approximation of this problem right here. And the 0.9018 is more accurate. And the normal approximation is more for if you need to make an approximation, you don't have any way to figure out the binomial. But it is good to know, and I wanted to show you how to use the normal approximation to find one as well. All right, that is everything for a binomial distribution, including a normal approximation of a binomial distribution, where you just find the mean and standard deviation and put those in. All right.